So today we're going to be talking about terminology and modeling polynomials. So for the terminology part, we're going to be using 3x2 minus 5x plus 4 as our example. So for terms, when we're talking about terms, we're talking about different things we have in our equation. So for our example we have here, we have three different terms. We have 3x2, then we have minus 5x. x2's and x's aren't the same, and then we have plus 4. So those are three terms. When we're talking about the coefficient is the number in front of the variable. And we haven't talked about it, but the variable is our letter in our equation. So in this example, we have 3, that's in front of our x2, and we have minus 5, that's in front of x. The degree of our equation, the degree would be the highest exponent. So in this case, we only have one exponent, and we have 3x2. So the degree of our equation or our polynomial would be 2. The constant term, and if we're using our example again, the constant term is the one with no variable. So over here we have plus 4. And a polynomial, we're going to see 3 different times. We have monomial. That means there's only one term. So 3x2 would be a monomial, minus 5x would be 1, and plus 4 would be 1. If we have a binomial, that would be 2 terms. So we could have 3x2 minus 5x, we could have minus 5x plus 4, we could have 3x2 plus 4, but only 2 terms. And a trinomial would be 3 terms. So 3x2 minus 5x plus 4 would be a trinomial. So over here, the arrows are pointing with the terminology we've just seen. So 5x2, 5 is in front of our variable, so that would be a coefficient. This arrow is pointing at our exponent, that would be the degree. Over here, minus 3x is in front of our variable, that would be another coefficient. The x, that's our letter, that's the variable. And the plus 4 has no variable, so that would be the constant term. When it comes to modeling coefficients, so we're going to be using red when it's negative, and we're going to be using yellow when it's positive. We're going to be using the tenths to represent x. Our little units would be the constant term, and we're going to be using 100 squares to be representing our x2. So in the first example, I have 4a. So, and here I put x's, but that's for every variable. So in this case, it's not to the power of 2. It is positive, so we're going to be using yellow, and to represent a's, we use these. And there's 4, so we place 4. The second example, we have 6, so those are constant terms. They're positive, so they're yellow, and we need to place 6. Minus 2p to the power of 2. So those are negative, so we're going to be using red, and they're p2s, so we need to use these. And those were all monomials because there's only one different term in each. For binomials, here we're going to have 2 different terms. So we're going to start with the first one, 2c. So like we've seen, red is for negative, yellow is for positive. These represent x's, these represent our constant terms, and these represent our x2s. So 2c's, they're positive, so they're yellow. We place 2. Negative 5, those are constant terms, they're negative, so they're red. and we need to place 5. 2m2 plus 3m. So the m2s are positive, and there's 2, so we're placing 2. Plus 3m, still positive, so still yellow. Now we have a trinomial. So there's 3 different terms. We're going to start with the first one, 2h2. So they're positive, they're yellow. We have 2. Minus 6h, negative are red. And there's minus 6, so we're placing 6. And for our constant term, we have plus 4. So we place 4. Over here, 3x2 minus 5x plus 6. So start with the first one, 3x2, place 3. Minus 5x, that's negative. Plus 6, that's your constant term, it's positive. Next example, minus 5 plus 6r plus 3r2. So we're starting with a constant term, it's negative. Plus 6r, that's positive. And plus 3r2. Next example, minus 5m, that's negative. We're starting here. Plus 6, that's our constant term, positive, so it's yellow. And plus 3m. Let's do one more example. 2x2 minus 5x plus 6. So we're starting with the x2s, plus 2, it's yellow, minus 5x, red, plus 6, that's our constant term, we need 6. Next example, minus 3w2 plus 4w plus 9. Minus 3w2, the red, plus 4, the yellow, 4w, I'm sorry, and plus 9, that's our constant term, and it's positive. Now if I give you a drawing of a polynomial and I'm asking you to name what is modeled there, we're going to start with this. These are x2s. I have 2, so we would write 2x2. These are x's. I have 8, 8x, and they're red, so they're negative, minus 8x, and those are constant term. I have 2, they're yellow, so they're positive. Over here, these are x's. I have 8, they're red, so they're negative. These are x2s. I have 2x2, and they're yellow, so they're positive. And here are my constant terms. There's 2, and they're yellow, so they're positive. Last example, these are my x's. I have 4, they're red, so negative, and these are constant terms. I have 6, and they're yellow, so they're positive.